We're going to start our unit on polynomials. This is chapter 6 in your book. It's also a topic that you guys covered in Algebra 2, so most of what we're going to be doing in this unit is going to be a little bit of a review for you. The main objectives of what we're trying to cover in this video is for you to be able to classify polynomials and also be able to add and subtract polynomials. So first we have some vocabulary we need to make sure you are reminded of. One is the degree of the polynomial, and we get the degree by looking at the largest exponent. So down here is an example of a polynomial. As we look at each one of these terms, when you find the largest exponent, so here 3 is the largest exponent, that means the degree of this polynomial is 3. The other thing we need to talk about is what standard form means. So a polynomial is in standard form when the terms are in descending order by degree. What that basically means is that you line up each term from the largest exponent down to the smallest exponent. So as you look at this one, the largest exponent is 3, then the next largest is 2, and it goes so on and so on. We can also determine the leading coefficient. Once the polynomial is in standard form, so the largest exponent is first, the leading coefficient of the polynomial is the number in front. There's a couple different ways that we can classify a polynomial. The first is to classify it by degree. So all of these are a list of ways that you would classify this by degree. The first one would be constant. A constant would have a degree of 0. An example of that would be 5, really any number. The reason why 5 is a constant or has a degree of 0 is because this is really 5 times x to the 0 power. Anything to the 0 power is 1, so this would be 5 times 1, which is just 5. So anytime you have just a number by itself with no variables, that's considered a constant. The next type is linear. That would be anything to the first power. So an example of that would be 2x. And the reason why this is x to the first power is because this is really 2x to the first. But anything to the first is itself, so we don't tend to write the exponent of 1. So any variable where you have a number and just the x would be a linear term, so if there aren't any exponents on it. Next is quadratic. That's going to be x squared. So an example of a quadratic term would be 7x squared. Cubic would be x to the third, so an example of that would be negative 3x to the third. Quartic would be x to the fourth, so 8x to the fourth would be an example of a quartic term. Quintic would be x to the fifth, an example of that would be 4x to the fifth. Then anytime we have a term that has an exponent higher than 5, we consider that the nth degree. So x to the nth, which would be any number higher than 5. So an example of that would be 12x to the 9th. We would say that is a 9th degree term. We can also classify polynomials by the number of terms that it has. So a monomial would mean that it only has one term. A binomial means it has 2 terms. A trinomial would be 3 terms, and then if you have a polynomial with more than 3 terms, we consider that a polynomial with n terms. So for example, if you had a polynomial that had 7 terms in it, you would classify that as polynomial with 7 terms. When we classify polynomials, we first classify it by the degree, and then we classify it by the number of terms. So an example of that would be a quadratic trinomial. That's something that we did when we did quadratics where we were factoring. We factored quadratic trinomials. It has a degree of 2 and it had 3 terms. So we're going to practice a little bit here. We're going to rewrite these in standard form, and then we're going to classify it using the 2-part name, so by the degree and by the number of terms. So this first one here, I'm first going to rewrite it. So if I rewrite it, it's going to be 4x plus 3. We have to go from largest exponent down to smallest. So this 4x would have a degree of 1, and the constant would have a degree of 0. So now I'm ready to classify it first by degree. So if it only has a degree of 1, that's going to be linear. It has 2 terms, so that's going to be binomial. So I would classify this as a linear binomial. The next one, b, when I put this in standard form, it becomes 8x to the fourth plus 3x squared minus 4. When I classify it, it is a quartic trinomial. Quartic because the highest power, the highest exponent was 4. Trinomial because it has 3 terms. This next one would be negative 2x squared plus 4x plus 2. When I classify it, it is a quadratic trinomial. Quadratic because the exponent is 2. Trinomial because there are 3 terms. And then this last one here in standard form would be x to the third minus 18x squared plus 2x minus 5. And then I would classify that by calling it a cubic polynomial with 4 terms. Make sure on quiz and tests you don't just write cubic polynomial. You'll lose points if you don't also include with 4 terms. Now we're ready to move on to adding and subtracting polynomials. When we write our answers, we need to make sure that our final answer is in standard form. So we need to find the largest exponent first. So when I'm looking at this, the largest exponent is 3 over here. When I look over here, also 3. So my first term should be x to the third. So I have 2x to the third plus another x to the third. That's a total of 3x to the third. Then I look for all of the terms that have x squared. There's only one, so that's plus 5x squared. Now I'm looking for all my linear terms. So I have a negative x and a positive 7x, so that's positive 6x. And then finally I'm gathering all my constants. I have a positive 9 plus 4 for a positive 13. Next example, when it's subtraction, I would encourage you to turn this to a plus and then change every single sign inside here. So this would be plus, and then it would become minus, minus, plus. That will help you not lose track of this, because remember, we're distributing this negative to every single term inside the parentheses. So we're looking for our largest exponent. I have negative 2x squared minus x squared, so that would be negative 3x squared. Then we're looking for our x's. I have a negative x here, but when I distribute this, it becomes a positive x. And then finally, we need constants. So I have 3 minus 6, which would be negative 3. There's another example of addition. So we're going to go through this one a little bit quicker, looking for our largest exponent. So I have 16x to the third. The next largest would be all of my x squareds. That becomes negative 30x squared. Now I'm looking for all of the x's. So I just have one, it's plus 6x, and now I'm looking for all my constants, negative 16. On this one, another example of subtraction. Remember, if it were me, I would turn this into a plus and then put a negative, put a little negative in front of this, and then turn this negative into a positive. So when I'm looking for the highest exponent, I found a 3, so my first term is going to be 5x to the third. Now I'm collecting all of my x squareds. I get negative 9x squared. Then I'm going to find all the x terms. I have negative 3x, and then finally the constants plus 14. So your homework on this section is going to be found on the next tab, so go ahead and complete that, and then you can move on to the next lesson.